Good afternoon, everyone, and welcome to WASA Distance Education. This is MBF3C, Foundation for College Mathematics, grade 11, and my name is Marvin. I'm just wanting to, share my screen now. There we go. So again, this is MBF3C, grade 11 Mathematics, college preparation. We are into the last week of classes for term 1. We will be having a class today, and then the class tomorrow, and the class on Thursday. So lesson 18 today, lesson 19 tomorrow, lesson 20 on Thursday, and that will finish up the course. So yesterday and the day before, but mainly yesterday, we looked at a problem involving standard deviation. So we did a couple of sample problems where we looked at a set of data. For example, practice problem 17.2, which we worked through yesterday, with a set of data, and then we rearranged the numbers from smallest to largest, or least to greatest. And then we determined the median, which is the number that's in the middle when the numbers are arranged from least to greatest. That's what we have to um, put them in order from smallest to biggest in order to determine the median. And the number is right in the middle. The mode is the number that occurs most frequently or most often. In this case, it was 18. The range is the largest number minus the smallest number. And then the mean is another word for average. Add up all of them, add up all of the numbers, then divide by the number of numbers. So those are things you've probably already seen before. You're able to do the calculations with ease. So not a difficult concept and something that you're familiar with. Standard deviation and variance are a different animal. So to do the standard deviation and the variance, which are related, and we'll get to them in a second, all you simply have to do is create a table with 4 columns. The first column is X, and X represents the values that are in the set that you're given. So we have 56, 30, 18, 42, 21, 50, 72, 14, 63, 18, 34. Those are the values that we were given. Those are the numbers we're using. So those numbers go in this column. Second column is easy. Once you find the mean, which is right here, 38, you put 38 in every single column or every single row in that column. So 38 all the way down. That's really easy to do. X minus X bar, so take this number and subtract that number. So 56 minus 18 gives us this one. Then we're going to take this number, what we have here, X minus X bar, and we're going to square that number. 18 squared is 324, and so on. So we did 2 examples like this yesterday. Once we get the 4th column, we get all of these values. Then we're going to add up all the values from the first one. So add up all of those values, and we'll get 4,010. So the the variance is simply this number right here, the sum of all of those numbers. So the sum of X minus X bar squared, which is this column right here, that column. All of those numbers added up, 4,010. That's what this number is, sum of all those numbers, 4,010 divided by N is the number of values we were given. We were given 11 values. So 11 minus 1 is 10. So the variance, and what we use for a variance is S squared, is 4,010 divided by 10, which works out to be 401. So that's the variance. The standard deviation is simply the square root of the variance. So we take this number and take the square root of it. So standard deviation, the letter S, is the square root of the variance, which is the square root of 401, which works out to be 20.0. It's 20.0 something. So if you take your calculator and you take the square root of, okay, turn it on first, square root of 401, you get 20.02498,439. But if you round that to one decimal place, you'll get 20.0. So that's why it's 20.0 and not 20. So the standard deviation is 20. So this one, the standard deviation was fairly large. In the example we did before this, the standard deviation was 5.6, which was much smaller. We had the same mean. So what that told us was this data is not spread out very much, and this data is spread out more. So we looked at that yesterday. We worked through those examples yesterday. There's an example in the material that you would have received as well. So if you follow the process using that table, and it's important that you make sure you do the calculations first up here, range the numbers from smallest to biggest, do all your calculations, find the mean, put all the values in the table, all the means in the table, complete these two columns, add up that last column, and then use the formula, sum of those numbers divided by n minus 1, and then take the square root of that number to find the standard deviation. Again, mean, median, and mode are measures of central tendency. Variance, standard deviation, and range are a measure of spread. So it measures how spread out the data is. So there's a difference. The three M's are middle or average or measures of central tendency, and range, variance, standard deviation are measures of spread. How dispersed the data is, how spread out the data is. So um, now we're going to move down and on to the next lesson, lesson number 18. And it is titled Data Distribution. And distribution, we're going to be looking at different types of graphs, okay, and how those represent data. We're looking at tables or charts, and then we're going to graph the data. And the reason why we like to use graphs is it gives us a visual of all of the numbers. So sometimes if you're looking at a bunch of numbers in a table, it's hard to determine if there's a pattern or not. However, if we were to graph those values on a grid, then sometimes it's much easier to determine if there is indeed a pattern or not. Sometimes there isn't. Okay. So distribution is different types of distributions. So it talks about histograms and a few other things in the material that you would have received. Black and white, you have that in front of you. I'm going to come down to where it's blue. And again, blue is new. So we're going to come down and I'm going to show you some examples where the graphs are a little bit prettier than what you see here. This was produced by using a graphing calculator. So it's pixelated. This should be a curve, but it's difficult to do on a small window in a graphing calculator. So I'm going to show you some um, graphs that are much neater, cleaner, and more visually appealing. So the first thing we're going to talk about is the difference between bar graphs and histograms. Now, we are going to be mainly concerned with histograms in this course, but it's good to know the difference between the two because you would have seen bar graphs by now. You would have drawn bar graphs in grade 9, grade 10. You may have even done histograms in grade 10, I'm not sure. And you may have even seen them in different courses like geography, history, and you've for sure seen them in newspapers or magazines, seen them on the news. So we're going to explain the difference between the two. So in a bar graph, so a bar graph is used, uh, and uses separate bars to show and compare different categories or groups of data. So on the horizontal axis, um, it's going to be categories. So it could be we'll see an example in a minute, but it could be like here, drama, chess, whatever. The bars can be vertical or horizontal. Most often they are vertical, but they can be horizontal, and there's spaces between them. And the reason why the spaces between them is to emphasize that the categories are distinct. So, for example, we could be talking about different sports. So, hockey, baseball, football, tennis, soccer. Okay, each one of those is a distinct sport. They're different, they're not the same. Okay, so that's when we use a bar graph, and then the vertical axis would be a scale, a number scale representing the number of people enrolled in each sport at a specific school, for example. Okay, here's an example comparing the number of students in different school clubs, drama club, chess club, sports club, or we could compare the number of students enrolled in each sport on each sports team. So the hockey team, the football team, the soccer team, baseball team, and so on. Okay? So each sport is distinct, it's different from the others. In a histogram is a graph that shows the frequency distribution or continuous data, numerical data. So the bars in a histogram touch, so there's no gap between them. They touch each other because the data represents ranges or intervals that are part of a continuous scale. So, for example, showing how many students scored within each mark range on a test. So, for example, how many people got between 0 and 9, 10 and 19, 20, 29, and so on. So, between 9 and 10, there is no number. So, it's continuous data. So, that's why the bars touch and there's no gap between them. So here's a neat little illustration that shows the difference between the two. So, and again, in a bar graph, bars do not touch. So you can see there's a gap between the blue, red and the yellow and the green. Histogram, the bars do touch, you can see. So here we have 30, 40, 50, 60, 70, 80, 90, 100. So between 30 and 39 will be in this bar, in the 40s, in the 50s, in the 60s, in the 70s, in the 80s, in the 90s, and so on. In a histogram, horizontal axis has continuous numbers, so a number line with no gaps. Okay, there are no gaps here. Between 30 and 40, between 40 and 50, between 50 and 60, and so on. So this bar will be between 30 and 39, 40 and 49, 50 and 59, and so on. Okay, so there is a good visual explaining the difference between the two. So let's try now. Like I said, in this particular course, we are mainly concerned about the histogram. I just want to show you the difference between the two so there's no confusion um, going forward. So here, let's make a histogram for this data, which lists all of the scores a basketball team had in the games in one season. We're going to make 6 bars. Now, sometimes what you want to do, first of all, is what I'm going to do here is we're going to do the range. And I'll show you why we're going to do the range. Okay, equals largest value, subtract the smallest value. Okay, so the range is going to equal the largest value. So let's go through the list. I'm going to get my marker here now. So we have 60, 62, 68, 71, 72, 74. Actually, these are all, oh, this is easy. They're already in numerical order for us. Oh, I made it too easy for you. So the range is going to be, in this case, the largest value is 95. And we are going to subtract the smallest value of 60. So the range is going to be 90 minus 60, 60, 70, 80, 95, so 35. So the range is equal to, and I'm going to make this red because this is the solution here now. Oops. Back to home and change that to red. And I'm going to center this and make that red as well. So what we have to do now is we want to make a range of data. So we're going to go from 60 to 95, which is 35. If we go, let's make that 7 bars. I'm making it 7 bars because the range is 35. And if I make it 7, the range will be 5. So this would go from 60 to 65. Okay, so let's go 60 to 65. Let's do 66 to 70. And then we're going to do 71, 66, and 66 to 60 to 65 is 5, 66 to 70. It's not going to work either. So let's see how we're going to work this out. 71 to 75. So if we go 60, 65, 70, 75, 80, 85, 90, we need to add another, we need to add another column to my, and I'm just using, oops, uh, I'm just drawing a table. I'm going to insert to the right. So now I have 1, 2, 3, 4, 5. I want 7 bars. So 1, 2, 3, 4, 5, 6, 7. So what I'm going to do is, oops, I'll move my mouse quickly and it, oops, now it makes it too small. So let's go to view and change it to uh, page width. Okay, so I'm going to have to draw. So I'll do this slow so that it hopefully comes out uh, as I want it to. So the first one, we're going to go 60, 65, 70, 75, 80, 85, 90, and 95. Okay. And so those are the points. And up the side, I'm going to see if I can do this now. That's I haven't so it's going to be uh that up the side is going to be a number of games. Number oops, trying to write sideways is of games. I'm better at this than I thought I would be. That's the number of games. So let's come back over to here. So here we have, it's going to be 76 to 80. Then we're going to have 81 to 85. And then we're going to have 86 to 90. And we're going to need one more because we need is 7. Okay, so I'm going to, this is going to be mess up my thing now. I think I'm going to come over here. No, I think we're going to go 91 to 95. Now, this is going to make it a little bit easier for us because the table has already been sorted from smallest to largest. So in a lot of times, that wouldn't be the case, and you would have to do it yourselves, like we did yesterday when we were determining the standard deviation. There's a set of numbers, and we had to rearrange them. It makes life a lot easier. So from 60 to 65, we have, so I'm just going to come into here. 1, 2, 3. So there's 3 of those numbers, 3 games. So what I'm going to do is I'm going to center those as well. 66 to 7. Oh, I know. Oh, I made a mistake there. So 60 to 65, we only have 2. 66 to 70, we had 1. 71 to 75. So 71 to 75, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 76 to 80. 76, there was 1, 2, 3, 4, 5, 6, 7, 8, 9. 81 to 85. 1, 2, 3, 4, 5, 6. 86 to 90. So 86, 1, 2, 3. 86 to 90, there was 3, and 91 to 95, there were 2. Okay. So there we have frequency will be the number of games in each of those ranges. So we are going to have to label, so this is a number of games, so I got to come back over here and I'm going to label, this would be, so we got to get up to, the most is 9, so 1, 2, 3, 4, 5, 6, 7, 8. Actually, let's get rid of that and let's come over here and let's do this. Tab down. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to add one more for good measure. Okay, get out of here, right here. So now I don't need, just ignore these 2 down here. So now I'm going to label my axis number of games. So we have just all here. Why am I not being able? Okay, get out of here maybe. I want to draw in red. Close it. Okay, now I'm seeing my arrow and not, so that's one. No, something was going on here. Erase this. Now change it to this. 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the first group, there was 2. So my bar needs to be 2. So what I'm going to do now is I'm going to come over to my table design and I'm going to come into here and I'm going to do what we call a fill. Where would I find that one? I haven't done this for a while. I want to fill that. I'm going to have to come back to home and do my fill, and let's make it a gray color. One bottom left hand corner. 2. Next one, there was 1. The next bar should be 9. So from here up to here was 9. Next bar would be 8. The next bar would be 6. Next bar would be 3. And the next bar would be 2. So there is a histogram depicting this data, which is the number of points scored and the number of games where they scored. So if you look at this, the numbers in the middle between 70 and 85, that's where the majority of the games are going to be, or the number of points you're going to get, usually between 70 and 85. There's a few games where they didn't get very many points. It's a few games where they got more points than normal. But that middle chunk is where most of the games are when this all dust settles and the games are over, that's usually how many points they have in each of those games. So that's how we do a histogram. We should also label the top here, and it should be scores by a basketball team or something like that. It should be written across the top here as well. We should always label. So let's do that now just to be, so scores by a basketball team. And again, it's difficult to write with a mouse, so please bear with me. There we go. So usually we find the range to determine how many bars we want. And if we have, like from here, 95 minus 60 is 35. So it's easy to go every 5. Or I could go 5 bars and then have the groupings by 7. So go 60 to 67 and so on from there. But typically 5, 10, 15s like that, that would be probably the more common way of doing it, let's say. So that's a histogram. And again, it's the bars are touching, continuous data. So 60 to 65, 65 to 70, 70, and so on. Actually, 60 to 65, 66 to 70, and so on. Again, if you have any questions about any of this, please feel free to reach out. Call me 807-738-2031. Shoot me a text or email me at marvin.osmond@nnecschools.org. So now we're going to look at different types of distribution now. And a common term that you're going to hear is the term bell curve. And the graph you're looking at on the screen right now is an example of a bell curve. And a bell curve represents a normal distribution. So a normal distribution is a distribution that is a bell-shaped, symmetrical curve where most of the data values cluster around the middle or the mean. Okay, so in this type of distribution, the mean, the median, and the mode are all equal. Now, it's there's not a lot of examples where you're going to find where they're bang on perfectly exact every single time. There might be a slight variation, but this is what a bell curve typically looks like, or this is what it does look like. The data is evenly spread on both sides of the center. Symmetrical meaning that the line in the middle acts like a mirror. So they're the exact same shape, but mirror image of each other on each side of the line. So an example might be heights of test scores in a large group often follow a normal distribution. So how tall you are or the test score. So if we're looking at the height of people in a certain grade, most people are going to be around the same height. There's going to be a few people that are going to be really short at the bottom end. There's going to be a few people that are really tall at the other end. But most people will be in the middle. That being said, I don't know if you heard, but there is a hockey player, 17 years old, playing in Kitchener, Waterloo, down there somewhere. He's 7 feet tall at 17 years old playing hockey. So he would be what we will call an outlier. Remember from yesterday, there are not many students or many kids that are 17 years old and 7 feet tall. That's quite rare. Okay, so he would be over on this end over here, and if someone's really short, they'd be on this end over here. This is a normal distribution, and it is a bell-shaped curve. Okay, so that's one type of distribution. Another one is what we call skewed. So skewed is asymmetrical, meaning the data are stretched more to one side. The location of the long tail, not the peak, is what gives this frequency distribution shape its name. A long tail on the right refers to a right skewed or positively skewed, while the tail on the left is a left skewed or negatively skewed. So here are some examples. So a right skewed, the tail, which is the shorter part, is over here, the flatter part. And this one here, the mode will be the number that's right there. Median will be about right there, and the mean will be over here somewhere. And then the left skewed is kind of flip that around. So an example of this sort of distribution will be income distribution. So how much money do people earn? So most people earn a salary that's around the same. The rich people who earn like in the millions of dollars would be over on this end over here, and the poor people would be over here. But most of the people are closer to the poor end than they are to the rich end. But there's a big bulge right here. The other one, the tail is longer on the left, so right here, and the most values are higher. So example would be age distribution. So there's a lot of people, in their 30s, 40s, and 50s, and fewer people down here, and there's a big drop off at the end. So this would be right here would be right skewed. This one is considered left skewed. So we have normal, right skewed, left skewed, and then we have one that's called bimodal. Bimodal has two peaks. So it goes up, comes down, goes back up, comes back down. So this would be a bimodal, two peaks, and two common values or groups within the data. Okay. So this happens often when you have data coming from two different populations. For example, test scores from two classes taught differently, two different teachers, two different groups of students. You might have an average of 70 and an average of 90, for example. It depends. For the group, heights of a group of people containing, so this might be a group of people that are adults only. This group might only be children. Okay. So just remember bimodal, two peaks. This one is left skewed because the tail is on the left. This one will be right skewed because the tail is on the right. And this one, which is the more common one, is a bell curve. Bell curve, there's a lot of things that we study in nature that would meet this sort of distribution. Okay. So those are the different types of distribution. Again, there are four of them. There are going to be questions where if if you're looking at just the numbers, it's difficult sometimes to get a visual of what type of distribution we're looking at, whether it's normal or bimodal or right skewed or left skewed. The easiest way is to, first of all, we come back up to here, this one right here, then we can see the numbers from smallest to biggest. So that if they're arranged from smallest to biggest, we can see maybe a little bit better or get a little bit better picture of what the graph might look like so. So this one here, it's not quite normal because normal would go up and down. So this one is more to the left, tails to the right. So this probably would be a right skewed, not quite normal. But again, if you look at these, as I said before, there's very few examples where you're going to get a perfect curve like this or like one of these two here. There's going to be maybe a slight variation, but this would be if you were to, so what we would do if we want to go from a bar graph to a distribution is we would put a dot in the middle of each one of these, like so, and then connect each of the dots. So I would come down, go up through here, and then come down. Oops, not much, not a really good curve, but see what I mean? I would put a dot at the top of each one of these bars and then draw a curve. Be easy to do on a piece of paper and using a pencil than it is on the computer using a mouse. Okay, but that's how we would see what type of distribution this is. So this, I would probably say it's a right skewed distribution. Okay, let's get this back in here. Okay, so let's check the time. Here's how much time we have. We're getting close to the end. Uh, so that essentially is this particular lesson. So if we come down, there's some support questions. These are the marks out of 10 on a given test to a class. Again, uh, make a chart. First of all, that's what I would do. And then how many of each one of those values and identify the type of distribution. Again, is it normal, right skewed, left skewed, or bimodal? Calculate the mean, median, and mode, and then label them on the graph. So that would be doing something like we did with these examples here. There's the mean, there's the median, there's the mode. So plot it right here. You can pick it from here and then draw a vertical line to put them on the graph. That's what you have to do there. And then this table here gives you the frequency distribution of annual salaries of employees in a company. So there are 28 people making $15,000, 36 people making $25,000, and so on. Graph distribution of the marks. That wouldn't be that would be of the annual salaries, it should say. Let's make that correction now. Annual salaries. Identify the type of distribution. Again, there are four. And then calculate the mean, median, and mode, and label them on the graph. So just like that first one there. Okay. And that's it. And then there is a key question. So if you can do that, the key question is similar. And then here we have redraw each of the distributions below and label on each where the possible mean, median, and mode are located and what type of distribution is represented. So which one is which, and then look at the examples that I gave earlier where it shows you where the mean, median, and mode would most likely be. In part D, now remember, there can be more than one mode, but there can't be two. So there can be two. So for example, part D, there's probably two modes, but there's only one mean and there's only one median. Okay. So you have to determine where the mean and the median will most likely be on that graph. And then there's going to be some where you have to do, like we did earlier in support questions. And then, of course, you're going to have to do a couple of those. But then again, these are not difficult ones to do. So it's just a matter of, it's really not any calculations to do. It's simply a matter of looking at the data and determining whether it is a normal distribution, a skewed distribution, or a bimodal distribution. And there may be somewhere you're dealing with histograms as well. Okay. So that's it for that particular lesson. So we are now completed all of these lessons. Sorry, all of lesson number, I think that was 18. So now we have two lessons to go, 19 and 20. So these deal with probability, which means what is the likelihood that something will happen? So for example, if you roll two die, what's the chances of rolling a 7? So 7 could be a 6 and a 1, a 5 and a 2, 4 and a 3, 3 and a 4, 2 and a 5, 1 and a 6. So people think that there's only 6 and 1. Well, no, there's 6 and 1, 1 and a 6 because there's two dice. So if you think about it, if you had two dice of different colors, one is red and one is green, and you roll them. Well, you could have a red 1, a green 6, or a red 6 and a green 1. So there's two ways you could get a 7 with a 6 and a 1. 6 and a 1, 1 and a 6. When you think about it. So how many ways are there to get a 7? 1 and a 6, 6 and a 1, 5 and a 2, 2 and a 5, 3 and a 4, 4 and a 3. So essentially the number 7 is the most common outcome when you roll two dice. If you want to get a 6 would be a 5 and a 1, 1 and a 5, 4 and a 2, 2 and a 4, or 3 and a 3. There's only 5 ways to get a 6. So that's Or, we could be talking about what's the probability of pulling a red card from a deck of cards? What's the probability of pulling a heart? What's the probability of pulling an ace? What's the probability of pulling the jack of clubs? So those sorts of things are what we're talking about when we're getting into probability. Uh, we're not going to start that today because we're going to run out of time. We're only got a couple of minutes left, but that's where we're going with this next lesson. And then flipping a coin. So we're going to look at flipping a coin, rolling two dice, dealing with the deck of cards. And what's the probability of um, each of those? So we'll do some examples, and I've got some additional examples put in for you as well. So we'll look at those starting tomorrow. So that's just how much time if we have for today. So I'll stop there and we'll move on tomorrow. Thanks for participating, and I look forward to talking to you again tomorrow. Bye for now.